All right, so today we are talking about relations and functions. And I just asked the question, what does anybody know of any of these words? And somebody said range. Range is like the distance of the highest number, distance between the highest number and the lowest number. And that would be a great definition for range if we were talking about median. All right, so we said range would be really good if we were talking about medium. That definition would be good, but in this case, we're talking about a function. So I can't remember who it was. Oh, Jaden said that it actually is the list of all output values, and it is. I'm going to add two more words to your list. Please write down discrete and continuous. Continuous. Okay. All right. So I don't think you necessarily need to write down this word problem, but you do need the graph that we're doing. Please take these notes and sketch the graphs that we're doing. So Beta drove to work at 45 miles per hour. She pulled over at a gas station to look for her purse. She then raced home at 60 miles per hour to find her purse. Graph her distance from home over time. So as we create these graphs, the one thing to remember is that your graph means nothing without labels. So we know that the line that goes on the horizontal axis, what do we call that? X-axis, and we're also going to label the vertical axis the Y-axis. And then we also need words, because if it's a story, we got to relate it. The graph is a picture of the story. Okay? So we're going to say our Y is our distance from home, and our X is our time. So if I were showing she's moving at a constant rate of 45 miles per hour, and then why does this line get horizontal? Why does it get horizontal? Yes. She takes a stop. She's stopping, and my distance is not increasing. Okay, this shows her stopping. Not going straight, but stopping. And then what's happening as she is going, what's the line going to do as she heads back at 60 miles per hour, Marcus?
Well, it's going to go closer to the x-axis because she's going closer to her house, and she's also speeding up to 60 miles per hour.
So what's the line going to look like?
Steeper slant.
Steeper, right? Because she's getting home faster, right? She's getting closer faster. So this graph has a special name. Does anybody know what it's called? It's one of those words. Yes. Yeah, it could be a function, but we don't know the...
Oh.
It is a function. Yes. It is not discrete. You're close, though. It is continuous. And that's because at every moment that she is traveling, we are graphing every second. We don't just graph the 1 minute mark, the 2 minute mark, the 3 minute. We graph all the time in between 1 and 2 minutes. Does that make sense? So this is what we call continuous. It is a continuous line. So I would sketch this whole bottom part. All right, so the next one. Martha will put a quarter in her piggy bank every day starting Monday except weekends. Graph her total savings over the first 10 days. So the way I decide to name my X and Y axis, like what words to use, is this is a relationship. These two things what are we graphing, first of all? What quantities are we graphing, Gregory?
We're graphing the amount of coins saved over 10 days.
Okay, so what might I label my two X and Y axis?
Your x-axis would be the amount of coins, and then the y would be time.
So, and they're using savings, so we can use savings. And the other one, generally I just call it time. I put it into one. Now, what depends on the other? Does the savings depend on time or does time depend on savings?
The savings depend on time.
So whatever is your depender becomes your y. So what do I put on my y-axis?
You would put the amount of savings.
Savings on the y-axis and time would be on my x. So I'm going to just, start listing dollar amounts. And notice my x and y axis, the values don't have to be the same. They have to be constant rates of change, but they don't have to match. Right? So as I graph this, what's it going to look like? Gregory.
It's gonna be a straight line or a horizontal line.
Okay, more specific than that. He said a straight line or horizontal. So what am I doing on day one? Yes.
It's just gonna go straight.
Okay. What am I doing on day one?
You're gonna, right. It's, can I just say one thing first? It's gonna be a line.
No, I asked, what am I doing on day one is my question. On my graph. How do I show this on my graph? Yes. Right, we're going to put a point there where, on 0 days, how much savings do we have?
0.
So we put a point there. On 1 day, I'm putting a point at 25 cents. Now what?
Put on
Yes.
You go to 50 cents and you save
50 cents for what? Where's my point going?
day 2.
Day 2, I always work across first. I go on day 2, I go this way, and then I go up to 50 cents, and that's where my point goes. On day 3, right, I'm going to go over 3 days, up 25 more cents, right? You guys with me?
Yeah.
And I'm going to keep going, and I'm going to go all the way on. Oh, why am I doing that? Why does it all of a sudden look like that? Sarah?
Because she doesn't get a quarter on weekends.
She doesn't get a quarter on weekends. The savings stays the same. She stays the same. Right? But then on Monday, Tuesday, she's back to her all the way up to day 10. If I were to continue this, I'd put a little. Now, what do we call this? Leo, why? What's different about this than the last one? Yes, right here.
This one doesn't stop. This one continues going.
It-
Within the other one, it stopped once she got home.
Okay. That's true, but that's not why it's called discrete. Right there in the corner.
It's,
Is it Scott?
yeah. It's not always going. It's one day and then you stop. Then you wait until the next day.
Yes, I'm not at day and a half. There's no point here. There's no point at a day and a half. I'm not putting money in at my 36-hour mark. I'm not doing it at the 12-hour mark. I'm only doing it once a day. It is not the in-between parts. Does everybody understand that? And so when you do not graph so I don't draw a line through this because the parts in between are not part of that situation. It's only on day 1 I put a quarter in. Day 2 I put a quarter in. There are 10 specific situations. It's not the time in between. When I'm driving, so we say this is discrete. Sorry. This is discrete. When I'm driving constantly. Right? I'm not stopping as I'm on the freeway. Every minute I'm driving. So that's why we connect the dots. Do you understand the difference between continuous versus discrete? Continuous, it's a line. Discrete, it's just points on a graph. These specific situations. It may continue. I could write that if I were to continue it, I would put, if I were going to continue this, say this is happening for the rest of, and I could do the next one like a little arrow like this. But it is discrete because I do not connect the dots at specific situations. Questions? We are going on to, let's look at some graphs. What is a function? What is a function? A function is a rule that describes a dependent relationship between two quantities, independent, dependent. A function is a rule that describes a dependent relationship between two quantities. We're constantly putting these quantities together and comparing them. One depends on the other. How much money do I make? Depends on how much time I work. My salary depends on my time put in. How much weight I gain depends how much food I eat. Or chocolate.
Chocolate's amazing.
All right.
I'm not talking about that.
So, let's keep going. So, we have our domain. And somebody said the range was our set of outputs. So, what is our domain? Our set of inputs. And when I say that, I mean our x values. So, you might see, it might be a number machine where I'm putting something in. Okay, this is my domain. Anything in here. And my y is my range. So it's the set of, what do we call the y? Our set of output values. It's like a number machine. I plug something in, I get it out. I plug something in, I get it out. What I plug in is my input or my independent. What I get out is my output or my dependent or my y. Yeah.
So do domain and range mark the efficiency of a certain thing? Because in science class they said that the relationship between input and output is used to mark efficiency.
I've never heard of it in those terms. We use domain and range to describe the relationship between the two.
Okay.
But I suppose that would be a definition. It marks the efficiency. Well, it describes the exact relationship between something. And it helps us to predict things. So, now let's go back to our domain and range. Can I move on? Or you guys, did you finish taking notes? You have all those? You know those rules? Are you writing fast? Okay, because we got a long PowerPoint today. All right. So, we're going to say this is a relationship. N stands for number of triangles, and P stands for our perimeter around the figure. So, what do you think depends on the other? What's the depender? Is it Sarah? Okay, Sarah.
The perimeter depends on the number of triangles.
Perimeter will depend on how many triangles. So, I'm going to create an X and a Y. The depender is like my Y. I'm creating that XY table. Okay? But I'm going to put P where the Y is because she said the perimeter is the depender. Okay? And N is my independent. Now, for N, for the first triangle, what would I write? How many triangles is the first triangle we see? Yes. One. And what would the perimeter be?
Perimeter, that would be
3. 1 to 3. And we're talking 3 units. We don't know what the units are, so we're going to just call it 3. Okay, next one. Leo. What am I going to put the next? What am I going to input for my next domain and get an output for my range? I'm looking at this right here. So what is my number of triangles? Because N stands for, notice I defined my unknowns. Do you guys see that? I'm not making you guess what N and P stand for. I drew the picture, I defined my unknowns, now I'm making the table. So what do we, N is what? 2 triangles. And what would my perimeter be?
4.
1, 2, 3, 4. Yeah. The perimeter is 4. Notice I don't count the lines in the center. Okay, what would the next one be? Somebody else. Right back there. What's your name? Janice. 3 triangles is what perimeter? 4. 1, 2, 3, 4. 5. Okay, stop looking at the triangles. Can we predict what the next ordered pair would be? For our input and output, wait, right back there. Wait. What's your name?
Me? Hannah?
Hannah.
It would be 4 to 6.
4 to 6. Tatiana, what would go next?
5 to 7.
5 to 7. And we can still predict 6 to 8. Now, if I graph it, what goes on the x-axis? What am I going to call that?
The triangle.
Number of triangles. And what goes on the y-axis? Perimeter. Okay? And remember, my values on the bottom don't need to match my values on the vertical axis. Okay? They can, they don't have to. So is this graph going to be discrete or continuous? He says continuous, he says discrete. Why do you say continuous?
Because it continues on, it's not saying, it's like it continues in the, okay. Because it can go on.
Let's graph it, Marcus. So 1 triangle, I'd put a point for 3, right? And 2 triangles, and 3 triangles. Are you seeing that?
Yeah, because it's going on forever, it's not excluding the inside part.
Okay, is that accurate?
No.
Yes.
No.
Why? Why?
Doesn't show between. It doesn't show like half of the triangle.
Yeah, can we do half a triangle? I'm not going to do half a triangle. If I did half a triangle and I sliced it, it will no longer be a triangle. It'll be open, right? So it has to be discrete. Does that make sense? You're thinking because it goes on and on forever and it has a pattern, it is continuous. No, continuous just means it includes all the data in between the dots. Does that make sense, guys? So in this case, now can we predict what the equation would be? My perimeter, you said, is the depender. So perimeter is equal to what? In the back there, Caitlin. And every time, number of triangles plus 2. And so if I use that equation and I input 2 triangles, I get out my perimeter. It's like a number machine. I input 3 triangles, I get out 5 perimeter. Does that make sense? Okay, so that's my dependent, my n is my independent. Okay, I'm moving on. I'm going to skip this example, and we are going to move on to, if we have time, we'll come back here. Okay, so let's look at this one. A car's fuel tank. This time, we're talking about minutes in the car, and amount of gas in my tank. What do you think? Is this situation going to be discrete or continuous? What do you think, Vivian? Okay, what do you think, Jaden?
I think discrete.
Discrete. What do you think?
It'll be continuous.
Continuous? What do you think?
Oh, continuous.
Okay. Who can tell me a reason why it would be discrete? Jaden?
I think it would be discrete because it's going per each minute and it's not going into seconds.
Do I get out of my car at the second mark? So at a minute and a half when I'm driving, my car's fuel in the tank is filled at 1.6 gallons per minute. That's what my rate of gas is. So if I'm driving right? Time in the car. At 1 minute I'm driving. At 1.5 minutes am I driving? Do I stop in between driving from 1 minute to 2 minutes? So it would be continuous. That's right. So I'm going to create what depends on the other. What's my X? What's my Y? What's my X? What's my Y? Sarah?
The gas depends on the number of
Gas is the depender. So what is that going to be? What is the depender? X or Y? Y. So my volume will be my Y, and my gas will be my M. And I can just pick random. You don't have to write this whole thing down. But as I graph it, remember, my X is going to be minutes. My Y is going to be volume. And you can see I'm going to connect them because between 0 and 2 minutes, I'm counting all that time as I'm driving. I don't stop the car. I only turn it on and turn it off. Is everybody clear on continuous versus discrete? Also, we have, we talked about independent and dependent. How to write the story on the graph, how to label our graphs. And this is our Y, is our vertical axis. X is our, always labeling those as well. All right. So we said, okay, so a relation is any set of ordered pairs. A relation is any set of ordered pairs. Okay? Domain, we said it is our set of input values, which is also what? Those are our X values. And our range, what do you think that is? Our Y values or our output values? Okay, so this is my X values. And these are my Y values. All right, so when it says state the domain and range of the relation, a relation is a set of ordered pairs. I'm going to say D is equal to, and since it's a solution set, there's more than one domain. I am going to list it. Marcus, what would my domain be?
Well, first of all, domain always comes first, so it's 2, 3, 4, 5.
Good. It is all my X values, right? It's always an XY ordered pair. Goes X, comma, Y. And how would I label my range, please? How would I label my range? How about next to Caitlin, what's your name?
Sadie.
Sadie Roberts.
It would be 5, 7, 9, 11.
Perfect. And I close my braces. Now, I'd like you to do number 2. Go. State the domain and range. Pause the recording. So let's begin. The domain for number 2, someone I have not heard from, please. Sydney.
-3, -2, -1, and 1 in brackets.
Perfect. Okay, now, yes. Question? Are you going to answer the range? Okay, so what would my range be?
It would be 10, 10, 6, 6.
She said 10, 10, 6, 6. Did I repeat my numbers?
No.
No, I did not. Not in my range. Look at how I wrote it. Now, this is like saying I want everybody in here with brown eyes and brown hair. Now, I'm not going to list Tatiana because she fits both qualities twice. I might put Sarah in there because she has brown eyes. But I'm not going to put Tatiana twice. I'm only going to put her in once. Who are the kids that match this, brown eyes or brown hair? I would put Sarah in. I would put Tatiana, but I'm not writing Tatiana's name down twice. Do you understand that? We're doing the same thing with domain and range. Okay, so a relation is any set of ordered pairs. This definition gets me every time. I'm a little bit dyslexic. I'm a little, my left, my right. I got to put my right hand over my heart to figure it out. Somebody says, move to your right, and I move to my left. So,
Everyone does that.
okay, recording. So, with this, I'm kind of like that with this definition. So, a function is a type of relation where there's exactly one output for every input. What I start getting confused is it one input for every output or one output for every input? So, here's the easy way to remember. No repeated x's. No repeated x's. Okay? So in this function, we are seeing a function in two different ways. Okay? We are seeing a function in two different ways. So the first function is what this means, 1, 2, 3, 6, 7, 7. The first one really means it's an ordered pair, right? 1, 6. And the next one's 2, 7. And then the last one is 3, 7. Does that make sense? So when I say no repeated x's, are there any repeated x's? No. So it is a function. So the big golden rule for whether it's a function is if there are no repeated x's. This, to the right, is what we call mapping. Okay? That should be an N. So what I do is I notice that this goes with this, right? It's 1, 6, so I draw an arrow. And then 2 goes with what?
7.
Good. And 3 goes with?
7.
So sometimes I might give you the map with the arrows and ask you if it's a function. Sometimes they might give you a table. If you're here and you see those arrows, just put it in ordered pair. Watch me. This is what I do. This is where kids get messed up. This means 1, 6. This means 2, 7. This means what?
3, 7.
Now make your determination. Is it a function?
Yes.
Because there are no repeated x's. So what makes it a function is no repeated x's is a function. Yes, Tatiana.
So that means in a graph, it would just always travel to the right and not just stop and then keep going.
Well, we're going to look at it in the graph. Give me a minute, okay? All right, now, so this is a function. Let's look at the next one. We're going to see the map. So one, I'm drawing my arrow to what? To the 6. And now what am I going to do? Marcus?
Arrow from 1 to 7.
1 to 7 and 2 to 7. If I write down those ordered pairs, just given this, I'll have 1, 6, 1, 7, 2, 7. I can tell from the table and I can tell from here. Is this a function?
No.
Why?
Because it has more than one x. Something.
Because why?
It has more than one x value.
X is repeat. So it is not a function. Do you understand how to identify it from the map or the table? They don't always give you both at the same time. Okay? So is this a function?
Yeah. I mean, yes.
Yes, it is a function because no x is repeat. Is this a function?
Yeah.
Because the x's do not repeat. -1 and 1 are different values.
No.
Okay, is this a function? Because the x's repeat. Not a function. Okay, let's look at y equals the absolute value of x. So I get to choose my x values. Remember, they're independent. So if I put some negatives, some positives, the absolute value of -2 is what?
2.
Good. The absolute value of... Do you see how I'm doing this?
Mm-hmm.
Okay. Is this a function?
Yeah.
Okay. And if I put it into a map, you can see All I do is go -2 to 2. Pause, just draw what the ordered pairs where it goes to. Now look at this next one. They switch the x and y values. They're making y the input and x the output or the result. So this time I'm choosing my y values, right? Choose some negatives, some positives. What's my y going to be?
2, 1, 0.
I mean, what for this one? It's going to be
Positive 2.
2, 1.
0, 1, 2.
Is this a function? And actually, when you look at these on a graph, this is how absolute value makes something that looks like this. It makes a V. Sorry, it should be more even, but I'm on the iPad still getting used to putting my hand down and I didn't. Okay? When it's like this, here's my x and y value, right? Here's y, here's x. It looks something like this. That equation. Okay, so now, which brings me to our graphs. Oh, is this a function?
Yeah.
Yeah.
Number 2, is it a function?
No.
Number 3. Number 4.
No.
Notice in the map, when it's not a function, 2 lines come out of the same input. Okay, so now we are on to our last way to tell if this is a function, and that is with our vertical line test. Now I'm moving over here and I'm showing them on here. So if this is my graph, and I run a vertical line through my graph, if I'm running a vertical line through my graph, okay, you can see that my vertical line never crosses the red line at 2 times in the same moment in time. It's only touching, oops. You see, it never crosses that red line at 2 times at the exact same moment. If it doesn't cross it at 2 times in the exact moment of time, we call it a function. When I cross the vertical line, when I pass it through, moving it, does it ever cross the red line at 2 times at the same moment in time? So is it a function? Yes. Okay. As I am moving my line, does it cross the line at least 2 points in the same moment of time?
Yes.
So it is not a function. Thus, vertical lines are never functions. Vertical. Not steeply slanted, but vertical. Okay? Now this one's tricky because you're not really that used to this shape, and this shape is called a parabola. Is this a function, Marcus?
Yes, it is.
It is, because if you were to continue this line, notice it's not vertical, is it? It's slanted. And you can see it never crosses at 2 points in the same moment in time. So it is, in fact, a function. Now here's where it all becomes very real. As I run my vertical line test, does it cross at 2 times in the same moment in time?
Yes.
So is it a function? No, not a function. Next one, is this a function?
No.
No. Who said no?
It is.
Okay, let's look. Let's take a ruler, and is it making a vertical line?
No.
So when I run a vertical line, it will pass through. As long as there's a slant, it's a function. It's only when you have that vertical. Okay, what about here?
Oh, not a function.
Not a function.
It has the absolute value to me.
What about here? This is x equals absolute value of y. Not a function. Now, we could also have, really quickly, if I gave you a graph that looks like this, okay, if I have a graph that looks like this, and I have something that looks like this, is this a function?
Yeah.
Run the vertical line test. Run the vertical line test with it. Is this a function? Yes. Okay. Is this a function?
No.
Okay. As I run my vertical line, I see that there are 2 points on the vertical line at the same moment. So since it crosses the vertical line, it doesn't pass the vertical line test, we say it is not a function. Yes.
Is there a program that can do the vertical line test and then
Hold on. Okay, so now, let's look at this one right back here. I want you to see this. If I were to turn this into a, I'm going to make this into, let's make a table of these values. Okay? Let's look at this point, and this point. What is the first point? What ordered pair is that? 0. Oh yeah, 3, 0. So it's 3, 0. What else? Marcus?
3, 1.
3, 1. What else?
3, 2.
3, 2. We can see in a vertical line, if you were to write down all the points, we see in the table the x's repeat. Does that make sense?
Yep.
Okay, so that is our vertical line test. Let's see what we got here. All right, is this a function? Number 1. Who said no? If you see 2 arrows coming out of your input, it is not. Okay? 2, is it a function?
Yeah.
There's no vertical line in it. If you look at this, at what point does it ever cross? Sydney?
Oh, I was talking. Oh, I'm
Okay.
sorry. When you said 2, I went.
Okay. So, number 2, is it a function? Yep. Okay, number 3. Number 4. All right. Number 1. Is it a function, Santi? Santi, thank you. What? Yes, it is a function. It passes the vertical line test. Number 2, right below our parabola. Is it a function?
Yes.
Why are you saying no? What justifies that answer? Yes.
I said yes.
Oh, okay. Okay. You can always take points on the line and set it up into the table and then look. Okay? Okay, so now it's asking us to state the domain. So look at number 1. Sorry, I didn't read the directions. It says state the domain and range. So we take every point, right? And we are stating, so this is 2, 2, right? 2, 2. This one, I would usually you go left to right. Are you guys clear on that? You find all the points. And so in this case, notice, for number 1, my domain is -2, -1, 2, and 4. I don't know why they didn't. Shh. So, guys, my domain is this. -2, -1, 2, and 4. Look at the parabola. On this case, my domain for, I don't know why this is like this. My domain, I'm going to write it like this. If I'm talking about the x is such that, just write this line, or you could just say x is such that x. If I were to make a table here, guys, pick points, right? Okay, what are these points I'm filling in my table? These are just some points that I'm filling in. Okay, what are my points on my table? Marcus.
You want to start off with the vertex, which is
You can go either way. Let's start with the...
0, -3.
Well, I'm going to start left to right. So -2, 1. -2, 1. The next one would be -1, -2. The next one would be 0, -3. The next one would be what? 1, -2. The next one would be 2, 1. Now, but I'm continuing. Are you seeing that? I'm continuing. So what if I continue in this direction? What are all my x values that I'm going to hit? Notice it's a slant. Isn't it going to eventually hit everything that way? Isn't it going to eventually hit everything this way? For my x values. So what do we say?
Domain equals all real numbers.
It's going to be all real numbers. That's right. It's going to be all real numbers. So when you see a parabola, do you understand? Because it's going in both directions, it's going to be all real numbers. Now, this is really messed up. Okay, so but my range, forget about the PowerPoint because it's really, hold on guys. My range